Let's solve this question together on circle geometry. This is what you have. And we are told O is the center of the circle. If you go to the circle, you will see that this is the center, and that's where you have this point O. Then we are also told PQT. Go back again. PQT. This line here, this straight line, they say is a tangent. Now, when you hear tangent, what does tangent mean? Tangent simply means a line, a straight line that touches the circumference of the circle. Remember, the circumference is the outer part of the circle. So a straight line that touches this circumference at a point, but does not cut through. It just passes or touches it at a point and goes out, but will not cut the circle. Look at this. You see this? This one is not a tangent because you see it cuts the circle at 2 points. But for a tangent, it will just touch the circumference at a point and then move away. So this is the one we call the tangent, and that is what you have, PQT. Now, what other information are we giving? And when you hear tangent, it reminds you of a theorem. Okay, let's continue. We are told tangent at this point, Q. And this means angle QOR. When you say this angle, QOR means the angle at the center letter. The center letter here is O. So if you go to the diagram QOR, you see where your angle is formed. And that's what the question said. Find angle RQT. So what you want to find now is angle RQT. Let me clean this so that we have space to work this out. Now, what do you do? How do you find this? What is angle RQT? Where is angle RQT? This is R, this is Q, this is T. So the angle at this Q is what you are looking for, RQT. That means you want to find this angle. Now, how do you find the angle? Let me teach you what to do. Now, remember we are told that this line is a tangent. And you are also told that this is the center. So whenever you have a circle drawn and there is a tangent, sorry, let me draw it well. So whenever you have a circle drawn and there is a tangent and there is a center, this center, the line from the center touching the circumference, you know, is what we call the radius. This line is the radius. So this line touching the tangent of a circle reminds you of a theorem. And what does the theorem say? The theorem says that the tangent and the radius are perpendicular. Tangent and radius theorem says that this tangent line and the radius are perpendicular. And what does it mean by perpendicular? They form angle 90. They form perpendicular angle at this point of intersection. So where the tangent and the radius come in contact, they form angle 90. So there is angle 90 formed here. Now, if you go to this diagram, what can you observe? You observe that this is the center and this line is the radius, because from the center touching any part of the circumference gives you the radius. And it means that there is angle 90 formed according to the definition. So the angle 90 formed is formed from the radius of the circle touching the tangent. You see the angle 90 we have formed, and we are asked to find this part. So how do you find it? That means you need to know this part so that you take it away from the total, which is 90, and it gives you the one you are looking for. So the question is, how do you get this? I'm going to teach you how to do that. Now, what do you do? Remember, this is your radius also, and this is your radius. And whenever you have a triangle where you have the two sides, remember, radius are always the same. So whatever you have here is the same because radius are the same. And you see that the angle formed here is 74 degrees. So if you want to find this angle here, which is this, what shape does this remind you of? It reminds you of isosceles. And for every isosceles, the two sides of the triangles are equal, which is the radius of this shape. So what happens? The base angle of the isosceles that has those lines that are equal. You see, those lines that are equal, the angle they form at the base are always equal as well. So how do you get this? Let's say that this angle here is x and this one is x. Let's get it to help us to get what you are looking for. So we're going to have 74 plus x is equal to 180 degrees. Why are we having these two places as x? It is because it is isosceles triangle. That is our reason for having it, because for isosceles, the base angles are the same. So why do we sum this to 180? Because sum of angles, let's write it this way, in a triangle is 180 degrees. Did you see? So let's work this out. We have 74, x add x is 2x is equal to 180. To get x, remove this, remember it's positive. To remove, you subtract. So we subtract 74 from both sides. And when you do that, we have, so this gives us 2x is, if you subtract this, is gone, is equal to, if you subtract this, it gives you 106. So what do you do next? Divide both sides by 2. So if you do that, this will divide, this will divide, this takes off. So our x will give us 53 degrees. That's the value of our x. So if this angle is 53, that means this part is 53. Did you see? So here is 53 degrees. And if it's 53 degrees, can we find angle RQT? Yes, to find angle RQT, we have, so we're going to have, let's take this off. So angle RQT is equal to 90. Remember we said this is 90 minus this angle we have formed. And what is our reason? The tangent and the radius form angle 90. So let's write it to form angle 90 degrees at point of contact. So with this, we can now conclude that this angle we are looking for, angle RQT, is equal to, subtract this from this, subtract 53 from 90, it gives us 37 degrees, and that is our answer. When you see this kind of question on circle geometry, how do you solve it? Let me teach you. Now, when you look at this, the question is asking us to find this letter T and H. Now, this is your circle, and this point is the center. This O, most times we use O to show center of a circle when we are dealing on geometry. Now, this O is the center of the circle. And does it remind you of something? It reminds you that when you have the center, the line from the center touching this part of the circle is the circumference, the outer part. So whenever a line runs from the center to touch that circumference, we call such a line a radius. Now, what is special about radius? Radius are always the same. You see that from here to here is radius, and from here to here is also radius. And what does it mean? It means that these two lines are the same. Does it remind you of something? Yes. It reminds you that, you see that this shape here is a triangle. And whenever you have a triangle drawn, such that the two sides of the triangles are equal, it is what we call isosceles triangle. And what is special about it? The special thing is that the base angle that those two lines that are equal formed, just watch this line, the angle it formed and the angle that this one formed here, the two angles are the same. We say that the base angles of isosceles are the same. And if you look at this carefully, see that this is the base, we have 43 degrees. Now, we want to first find the value of H. What do you think we should do? Since we have said that these base angles are the same, these two angles are the same, it means that if here is 43 degrees, automatically this angle here should also be 43 degrees. What is your reason? Your reason is base angles of isosceles triangle. That is my reason. Now, if this is true, what do? It will help us to find the value of H. So to get the value of H, you see that this has complete the angles of a triangle. So we're going to have it as 43 plus 43 plus this H should be equal to 180 degrees. What is your reason? Sum of angles of a triangle is equal to 180. So quickly add this up. This will give us 86. This is 86 plus h is equal to 180 degrees. Now what do? You need to remove this. Is positive. To remove it, you have to subtract. So you subtract 86 from the both sides of the equation. And when you do that, this will go off. So we are going to have h is equal to, subtract this, it gives us 94 degrees as the value of h. Now that we have found this value of h as 94 degrees, let's now find the value of t. So to find the value of t, remember our h from what we got is 94 degrees. Does it remind you of something? It reminds you that whenever you have an arc of a circle, the arc is a part of the circumference. If this arc forms an angle at the center of the circle, let's take this as the center, and the same arc forms another angle at any part of the circumference, if you complete this, this is what you have. Did you see it? Now, what does the theorem say? It says that the angle you have at the center, if it is the angle you have at the center and the one you have at the circumference, if this one at the circumference is x, the one at the center will be 2 of that one at the circumference. Angle at center is 2 times the one at the circumference. And what does it mean? You see that this is the arc of this circle that forms this angle at the center. Did you see it? This arc forms an angle at the center, and the same arc of the circle forms another angle at the circumference. Did you see it? Which is this angle T. So to find T, obeying what you have stated here as the theorem, we can say that angle T is equal to, if here is T and here is 94, to get this value, we are going to divide 94 by 2. And when you divide 94 by 2, it gives us 47. And that is the value of angle T. So we have 47 degrees. Our reason is angle at center is 2 times angle formed at any part of the circumference. How will you react to this question when you see it? Let's do it together. Ifan gave it to us. Now, for you to answer this question, I'll just remind you of some circle properties that will help us to answer this. Now, remember that when you draw a circle, this is your circle. We say that this part of the circle is the circumference. And if this is the center, a line that runs from this center to touch the circumference is what we call radius. It can run from any part, or you can do it this way, do it this way, do it. They are all radius and they are all equal. Now, in this question, you observe that we are given this and we have a center. We have 2 radii and you are having an angle here. Just watch. Look at this. Did you see? Now, if this is the center, you also know that you can also extend another radius from here. Move it up, move it up. Did you see? It takes off. This is also your radius. And if this is your radius and this is your radius, I told you radii are always the same. So radius are equal. So it means that this part, which is the radius, is also the same with this part. And if this is true, look at the shape it gives you. It gives you a triangle that has 2 parts to be equal. And if this happens, we call this kind of triangle isosceles. And what is special about it? The special thing is that these lines that are equal, it forms an angle at the base. And the angles we form at the base are always the same. So if this place is 50, here will also be 50. Now, if you watch this, you see that this is your new radii, and this line and this are equal. So the angle they form at the base and the one they form here should be equal. Now, if this one is 31, this one it forms here is 31 degrees, automatically this will also be 31. Did you see that? And what is your reason? We say that base angles of isosceles triangle. Now, what do you do next? You have seen that this place is 31. So let's adjust this. So from the question, let's separate this. So some part of it here becomes 31. Here is 31. Remember, the total angle here is what we have as 3x. Now, what do you do next? Observe also that this is your radius, and this line is also your radius. So it means this and this are also the same. Apply the same property. It means that if here is 32, here will also be 32. Did you see that? The same reason these angles of are isosceles. Now, what do you do next? Have you observed that the total angle you have at this point now is this? So if this point is represented the 3x, what you will now do is the total angle here should be equal to 3x. So if you want to answer this question, what do? Let's take this off. So we're going to now have, so this gives us 31 add 32 is equal to 3x. Your reason, which you have stated here, is because base angles are the same. Base angles of isosceles are the same. So we're going to solve this. Add this, it gives you 63 is equal to 3x. What do? Remember that 3x is also the same as equal to 63. So divide both sides by 3 because these two are multiplying. So to remove multiplication by 3, you divide. So when you do that, this takes off. So we have x is 3 here is 1, 3 here will give us 2, 3 here will give us 2, and 3 here will give us 1. So our x is equal to 21 degrees. Now, to answer this question, we are asked to find the value of n. So what you just need to do is to remember a theorem. And which theorem should you remember? You observe that when you look at this part of the circle is the circumference, this outer part. Now you observe that there is a shape that is drawn inside this circle. And that shape has, just watch the bigger shape, concentrate on the bigger shape. You see that this is the bigger shape. Did you see? Did you see this? This is the bigger shape. And what kind of shape is this? We call it a quadrilateral. And this quadrilateral, you observe that the point of contact, the vertices of the quadrilateral, the vertex or vertex is where two lines meet. Wherever two lines meet, we call it the vertex. When there are many, we say it's vertices. So the vertices of this quadrilateral is touching the circumference of the circle. Did you see? And since it is like that, there is a theorem that says when I have a circle and there is a quadrilateral drawn such that the vertices are touching the circumference, the angle this makes here and the one it makes in opposite, when you sum them together, it gives you 180 degrees. The theorem is the sum of two opposite angles of a cyclic quadrilateral is equal to 180. Now, if this is true, this one is already 76. Now, how do we find this angle? When we find this angle, it will help us to get the value of n. Remember, this line is not a diameter because there is no center or any point, it doesn't show you the center. So don't call it a diameter, please. This is a chord. So to get this value, what do? Just add these two together and it should be equal to 180. So here is 76. We can say here is A. So to get this, we can now say A plus 76 is equal to 180 degrees. So to get this A, we just need to subtract from both sides. So subtract this. When you do that, let's do it here. Our A is going to be, this will go off. Subtract this, you have 104 degrees. So this value here is 104. And if this is 104, will it help us to find L? Yes, because when you look at this triangle also, you observe also that this upper part of the shape has a triangle drawn. Look at the triangle. And what is special about the triangle? There are two lines that are marked. This marked line shows that these two sides are equal. And if this angle is 104, how will you find n? What type of triangle is this? We call it isosceles because the two sides are equal. And if this is true, the base angle of those sides that are equal are also equal. So the angles formed at this place are the same. So if here is n, automatically here will also be 10. Will be n, sorry. So we said that these angles, let's write it here. these angles of isosceles are always equal. That is our reason. So with this, can we find the value of n? Yes. So we're going to have 104 add this n is equal to the total angles in a triangle, which is 180 degrees. So what do? This gives us 104. Add this, it gives you 2n is equal to 180 degrees. Let's work it up here. So to get this, so we have 104 plus 2n is 180 degrees. So what do? Remove this. To remove it is positive. So you subtract 104 from both sides. And that gives us, this will take off. So we have 2n is, if you subtract this, you have 76. To get n, these two are multiplying. To remove 2, you divide both sides by 2. So when you do that, n will give us, divide this, this is 1, this is 3 remaining 1, this is 8. So n is 38 degrees, and that is our answer. Carefully look at this question. Is this something you can do? Can you remember any theorem? Just look at it. Now, let me help you. If you've been following my tutorial, I told you that when you draw your circle, that this is the outer part, we call it the circumference. And whenever a line touches that circumference at a point, we call this line the tangent. And when you hear about tangent of a circle, it reminds you of a theorem. Now, to answer this question, you observe that this is the outer part of the circle, and this line is the tangent. Did you see it? It's touching it at this point. Now, there is another line that is very important in this circle. What is that line? Did you observe that? This is the center. Just watch. From A to B, from these 2 points is the center. This has told you, I always tell you that whenever you see O drawn on a line and it's in, just watch it. It say that it's almost just in between the circle. We call such a line a diameter. So if this is the diameter, it also reminds you of something. It means that I can draw and I can construct a radius from this center to touch this point of the tangent. And when I do that, it reminds me of something. For each time you draw a circle and there is a tangent line drawn and there is a center such that a line from the center touches the tangent at a point of contact, we say that it forms angle 90. Now we call it the tangent and the radius theorem. Now, what use will this be to us? If you go to this, you see that we have already gotten our radius. From here to here is our radius. It means that the line, this radius makes angle 90 with this tangent. Did you see that? Now, what other information do we need to grab? This one also is our radius. Did you see it? And if this is true, you observe that this part, if this makes angle 90 here, is also does same here. So this is also 90. And you see that this part from this radius, draw it out, touching this gives you also 90, the same theorem. Now, what do? This part of the circle, this part is already measured out, and that part is measured as 64. So if you want to get the remaining part that completes this right angle, what do? You just subtract. So to get this remaining part, this tiny part, because it's going to help us in what we want to do. So let's get this remaining part. So it means that to get this, we are going to do 90, which is the angle it has already made, minus 64 degrees. What is our reason? The tangent and the radius theorem. That's your reason for doing this. So when you do that, subtract this, is going to give us 26 degrees. It means that this angle here is 26. So let's take this up. So it means that this angle formed here is 26 degrees. So that when you add it with this 64, it gives you the total of 90 made between the radius and the tangent. Now, what will you do next? Having found this, you also know that this is the radius and this is also the radius. Did you observe that this has formed a triangle? Just watch. It's forming a triangle already. So it reminds you of something. And what does it remind you of? It reminds you that when you bring that triangle out, drawn this way, you see that these two radii are the same. Radius are always equal. So if here is equal with this, here is already 26 degrees. Now remember, for every, we call this kind of triangle isosceles because the two sides are equal. And if the two sides are equal, the angle that line forms at the base are always equal. So the angle it forms here and the one this line forms here are equal. So if this angle here is already 26, the base one here will also be 26. We say base angles of an isosceles triangle. So that's our reason. So it means if you go to the diagram, here is already 26, this part. It means that this place will also be 26 degrees. And because it is base angle of isosceles. Now, having gotten all this, what will it be of use to us? Now, what you need to do next is, you see where the angle X you want to find is located. You are free to bring out the shape. Just what the shape I want to bring. Did you see the shape? This triangle. So let me bring out that triangle. This is what I have. So I have something like this. And here is 26 degrees. This place is the X I'm looking for. And at this place, we have two angles formed. One is 90 and one is 26. So you are going to have 26 plus your 90 is the angle you form here. So to get X, what do? It has formed a triangle. So add all the angles together and equate it to 180, sorry. So plus X is equal to 180 degrees, sum of angles of a triangle. So if you add this together, this is going to give us, add this, it gives you 52, add this, we give us 142, and X is equal to 180 degrees. This is positive. To remove this, you subtract. So you're going to subtract 142 from both sides. And when you do that, this will go off. So we have X is equal to, if you subtract this, it gives you 38 degrees. And that is the value of X. Let's read the question first. TA, this is the circle we are given. So TA is a tangent to the circle at A. Now, when you hear tangent, tangent is a straight line. Did you see? At A, this is A. So it means that TA, this line, is a tangent line. And tangent is a straight line that touches the circumference. This part of the circle is the circumference, the outer part. So when a line touches it at a point, but does not cut across, we call this line a tangent. And another thing the question said is that if angle BCE, now when you have this, the angle mentioned is the second letter. BCE means angle at C. So the angle at C, go to the diagram, BCA, BCA. That means this part of the C, not the whole C, but some part of it. Did you see? This part of it is 40 degrees. Now, what other information? Angle DAT, that means the angle at A. So go to the diagram, DAT. Did you see? The angle formed here is 52 degrees. Now, what did the question say? The question say, find angle BAD. Angle BAD, that's angle at A. So go to the diagram, BAD is the whole angle at A. That is what this angle, the interior angle of A, is what you want to find. So how do you find this? Let me teach you how to do that. So we are going to let's clean this up so that we have space. Remember I told you that when you draw your circle, that a line that touches the circumference at a point, which we call the tangent. If I draw another line inside the circle, we call a chord. A chord is a line that runs from one part of the circle to the other without passing through the center. So if I draw a line from here and it touches this tangent at a point, the angle this chord makes with the tangent at the point of contact, this angle here, is equal to the angle in the opposite segment. Just watch, let me complete the diagram. So the angle the chord and the tangent makes at the point of contact, this one here, if it's A, It is the same as the angle it makes in the opposite segment. This place, just watch. So this angle A will be the same with what is here. We say it is the tangent and the chord theorem. So the tangent and the chord theorem is what we applied here. Now, can we apply it here? Because we want to get the value of BAD. So what do? This is your chord, this is your tangent, sorry, and this is your chord. Did you see? This is your chord. Please be careful. This line is not a diameter line. There is no center here. So had it been we have a center O, it becomes a diameter. And because there is no center, it is not a diameter, and the question did not call it a diameter. So please, it's a chord. Be conscious of such lines. So what it means is that this angle, which the chord and the tangent forms at this point, this angle 50, just take it back to this triangle, did you see? Is equal to the angle in the opposite segment, obeying what we have here. So it means that if here is 52, this place will also be 52. What is your reason? My reason is tangent and the chord theorem. Now, having done this, what do you do next? You now remember also that you see that the whole angle at C is now adding this together. So it means that if I add this together, it's going to give me 40 add 52 will give me 92. So we can say that angle BCD is equal to 92 degrees. Now, will it help us to find this BAD? Yes, because if you have a circle drawn and there is a four-sided shape, which we call the quadrilateral, drawn inside the circle such that the vertices of that quadrilateral is touching the circumference of the circle. These are the vertices of the quadrilateral. This place where two lines meet. So because the vertices are touching the circumference, the angle this one makes here, if it's A, the one it makes in the opposite, if it's B, if you add them together, it gives you 180 degrees. We say that the sum of two opposite angles of a cyclic quadrilateral is equal to 180. So if this is true, does it have anything to do with this? This is your quadrilateral. Just watch the shape. Did you see it's four-sided? And because it's four-sided and the vertices are all touching the circumference, did you see it? It means you are free to apply this theorem. So if you do that, what will you get? It means that this angle plus this angle should give us 180. So we are going to have 92 degrees plus BAD plus angle BAD is equal to 180 degrees. Our reason is opposite angles of a cyclic quadrilateral summed together is equal to 180. So remember, this is positive. To remove it, subtract 92 from both sides. This will go off. So we have angle BAD is equal to, when you subtract this, it gives you 88 degrees. And that is the value of the angle we are looking for. And I hope you learned something. Don't forget to like, share this video. See you in my next class. Bye.